Okay, Assalamualaikum and hi everyone. Alright, so hari ini kita akan continue into a new chapter 6 for chemical equilibrium. So what is chemical equilibrium? Okay, equilibrium or keseimbangan. Okay, alright, so let us look into our next video. Okay, alright. So for chapter 6 chemical equilibrium, it is divided into 3 parts. Okay, part 6.1. Okay, yang mana kita akan discuss di dalam chapter di dalam video ini. Okay, and then 6.2 okay to be discussed in our next class. 6.2 equilibrium constant and 6.3 Le Chatelier's principle. Okay, right. So untuk learning outcomes, dia adalah terdapat 3 learning outcome untuk 6.1. Okay, the first one is we are going to explain the reversible reaction, dynamic equilibrium and law of mass action. Okay, number 2, we're going to state the characteristics of a system in equilibrium, and number 3, we are going to interpret the curve of concentration reactants and products against time for a reversible reaction. Okay, so kita tengok dahulu the concept of equilibrium. So concept of equilibrium terbahagi kepada dua, iaitu reversible reaction and non-reversible. Okay, tindak balas berbalik dan tindak balas yang tidak berbalik. So untuk reversible reaction, dia akan go in both direction. Okay, maksudnya dia akan pergi ke arah forward dan reverse. Kalau untuk non-reversible, it's only proceed okay for one direction. For reversible reaction, okay, after some product are formed, the reverse process begins to take place and reactant are formed from product. While for non-reversible reaction, the reaction proceeds toward the formation of product. Okay, ini adalah simbol untuk reversible reaction. Okay, adalah simbol yang berbalik. Okay, kita akan gunakan half-headed arrow, separuh ke hadapan, separuh ke belakang. Okay, and then kalau untuk non-reversible reaction, okay, kita hanya menggunakan satu arrow ke hadapan sahaja. Okay, non-reversible sebab dia tidak berbalik. Okay, ini adalah the example. This is the example of reversible reaction, which is SO2 plus O2 produce SO3, okay, 2SO3. While untuk non-reversible ialah KClO3 produce KCl plus oxygen. Okay, so kita tengok dahulu untuk reversible reaction. Reversible reaction ialah is a chemical reaction that can be proceed in both forward and reverse reaction. Manakala dynamic equilibrium, okay, untuk dynamic equilibrium bermaksud reactant dan product concentrations stop changing because the forward and reverse rates has become equal. Jadi di sini kita boleh tengok rate forward equal to rate reverse. So ini adalah karakteristik of a system in equilibrium. Let's say kita ada satu sistem, okay, a chemical equilibrium can be established only in a closed system. Okay, closed system bermaksud sistem yang tertutup. Okay, alright. While untuk rate of forward reaction equal to rate of reverse reaction, dia contohnya kita boleh gunakan di sini adalah N2O4 produce N2NO2. Okay, ataupun kita boleh tengok di sini rate water flow in, okay, in the tank is equal to rate of water flow out. Jadi kita boleh tengok take this example, kalau air yang masuk, okay, sama dengan air yang keluar, maksudnya dia punya takat air di sini tidak berubah. Okay, alright. Equilibrium can be reached from both direction. Microscopic properties such as concentration, reactant and product, pressure and color are constant. Okay, jadi ini adalah example untuk N2O4 yang telah mencapai equilibrium. After time T1, okay, selepas masa T1, concentration N2O4 and concentration NO2 remain unchanged. Jadi selepas ini, so kita nampak dia tidak berubah. Maksudnya dia tiada peningkatan sama ada naik ataupun ke bawah. Okay, so pada selepas T1, okay, it is said that the system is at equilibrium. Okay, keseimbangan telah tercapai. But equilibrium concentration of NO2 and N2O4 are not the same. Jadi concentration dia tidak sama. Okay, right. Jadi katalah di sini kita start dengan NO2. Okay, we start with N2O4, the second one. Okay, kalau untuk the third one, okay, you start with NO2 dan juga N2O4. So ini adalah graf untuk N2O4 dan NO2 against time. Okay, so look at this slide. So in this slide kita akan discuss macam mana bila equilibrium reaction does not mean, okay, the amount of product and reactant are equal. Okay, so if the product react more easily berbanding dengan reactant, okay, but both rates are very slow. Okay, kalau produk yang bertindak balas dengan lebih mudah. Jadi kalau produk yang di sebahagian C dan D. Jadi kalau C dan D bertindak balas, dia akan produce A and B. Meaning that we can say that the equilibrium is shifted to the left. Dia akan bergerak ke sebelah kiri. So bila dia shift to the left, okay, there will be a higher concentration of reactant. Sebab apa? Because C and D sudah bertindak balas, jadi dia akan produce A and B. Jadi kalau higher in reactant, we can say that ratio of products over reactant is less than 1. Meaning that product, okay, product and reactant less than 1. Product over reactant. Okay, if the reactant and product both have similar reaction rate, the equilibrium position will lie in the middle. Jadi dia tiada perubahan lah, because A and B tindak balas kadarnya sama dengan C dan D. There will be the same concentration of reactants and product. Okay, so concentration, reactant and product sama. So we can say that the product over reactants is equal to 1. So it will be equal to 1 kerana sama, A and B sama banyak dengan C and D. So if the reactants react more easily than product, jadi kalau reactant react lebih banyak, okay, A and B dia akan bertindak balas. So apakah hasil dia? Dia akan dapat C and D, di mana C and D adalah product. So the equilibrium akan shift to the right. There will be a higher concentration of products. So the ratio, okay, products over reactant is greater than 1. Okay, maksudnya di sini product lebih banyak daripada reactant. But okay, please keep in mind that okay, the equilibrium is a dynamic equilibrium. Okay, keseimbangan merupakan adalah dynamic. So apa maksud dynamic? Dia bermaksud selepas T1 the reaction tidak akan berhenti. Okay, the reaction will not stop. Dia akan berlaku tetapi dalam kadar forward and reverse sama. Rate of forward reaction equal to rate of reverse reaction. So there will be no net change in concentration of A dan juga B. So hukum keseimbangan kimia, law of chemical equilibrium. So law of chemical equilibrium states that the equilibrium concentration of reactant and product are related by law of mass action or law of chemical equilibrium. Okay, hukum tindakan jisim ataupun hukum keseimbangan kimia. So for any equilibrium at given temperature, the multiplication for concentration of products, each raised to a power to its coefficient in the equation, divided by the multiplication of the concentration reactants, each raised to a power is equal to its coefficient in the equation is a constant. So apakah dia? Maksudnya di sini, okay, dia boleh disimplify menggunakan, okay, katalah kita ada satu equation A plus B produce C plus D, di mana A adalah bahan kita, B bahan kita, okay, A plus B produce C plus D. So A kecil, B kecil, C dan D adalah perkali, okay, perkali dalam tindak balas. Jadi kita boleh tuliskan dia sebagai K is equal to concentration of C kuasa C times concentration of D kuasa D over concentration of A power of A and B power of B. Okay, di mana K ialah equilibrium constant, then square bracket bermaksud concentration, and A, B, C and D is stoichiometry coefficient. So kita akan discuss further this part di dalam chapter 6.2. Alright, so that's all for this video. Thanks for watching.